Alright, so today is Friday, November 15th, 11/15. We are on End Behavior of Polynomials. Today is our dancing day. Alright, is there a quiet raised hand that can read the objective? Beverly.
Use properties of even and odd functions along with this by determining that the
There it is. So let's make a quick little chart of what's going to happen in terms of the functions. Down here, we're going to make a chart of their graphs. Notice the difference between functions, graphs, functions, graphs, functions. All right, so the trick here is to look at the leading coefficient. Ignore everything else. So when I say even and odd, I'm talking about the multiplicity, by the way. Multiplicity. Or another way of thinking about that is what power. So these are like the powers. Positive, negative, that's obviously the sign. Is it positive? Is it negative? So I'm only looking at the leading coefficient. So give me a leading coefficient that has an even power and that has a positive coefficient. And you guys can just shout this one out. Someone shout out something that has a positive coefficient with a variable that has an even power. 2x to the what? 2x to the second. Perfect. 2x to the second plus 3x minus 1,000. This is a positive even function. I'll give you, well, you guys should do another one. I'm going to do an example. You do your own examples. Do not copy this one. So this next one, I'm going to say something like 13x to the power of 6 minus 15x to the power of 5 minus 2x plus 7. This is also a positive even function because it has a positive first number and it has an even multiplicity or an even power. I don't know if I'm using the word multiplicity correct, but I'm definitely sure that I'm using the word power correct. I'll have to check that later. Let's try an odd power. That's still positive. So it's positive and odd. Someone give me a quiet raised hand for this one. Quiet raised hand, Ellery. 2x to the third. Perfect. That is a good leading coefficient because it is a positive coefficient, an odd exponent, and I can continue writing in, I don't know, like plus 2x squared minus 7x plus 10. That is a function that has a odd power and a positive coefficient. So this is a positive odd function. You make your own example for the next one. A good example would be something like, I don't know, 22x to the power of 99 minus 13x squared plus 7. That is also a positive odd function because it has a positive coefficient and odd power. Quiet raised hand. Something that has a negative even leading coefficient. Negative even coefficient. Someone that has their card, preferably. India?
negative 5x squared.
There it is. Negative 5x squared, and then you can add in other stuff. That doesn't matter. All this stuff, you can kind of cross it out. It doesn't matter. I only care about the leading coefficient. So 5x squared plus 17x minus 7. Sure. You make your own example for a negative even function. How about negative, I don't know, 12x squared, 12x to the power of 6 minus 8x to the power of 3 plus 13x.
The other numbers don't really matter, right?
The other numbers do not matter. You can fill in any random numbers that you want. And finally, quiet raised hand. What is a negative odd leading coefficient? Negative odd leading coefficient. Someone that has a card still. Otherwise, we have good backups with Beverly and Ellery and India. Someone that has their card still. Come on, give me a negative odd. Loria. Negative 10x to the third. Perfect. Negative 10x to the positive 3. And you can fill in whatever you want over here to the right-hand side, plus 2x squared minus 13x. Sure. You make your own example of a negative odd leading coefficient. So something like negative, I don't know, 11x to the power of 77 minus 5x to the 22nd. I'm just going to leave it like that. Question, India.
So did you test like negative 12x, that's an odd function, correct?
Yes, so that would be a good example right here. If I want another odd, I can just have negative 12x. That is a negative odd. All right, so we know how to distinguish just by looking at the function whether it's a positive even, positive odd, negative even, or negative odd. Let's go ahead and learn our functions. After we learn our graphs. Once we learn our graphs, then we are going to do the dance. So, graphs here. So here's a trick. Whenever we're doing our dance, your right hand, what's happening in the right side, if it's going up, that's going to be positive. If it's going down, it's going to be, it's positive, negative. Right hand up, positive. Right hand down, negative. That means on the right hand side, I don't know what's happening on the left hand side, but as long as my graph over here is going up to the right, then that is an example of a positive function. Another positive function, I have to be going up to the right on the right hand side. The difference now between even and odd is that even, they're both going the same direction. Odd, they're going different directions. So I think of even as kind of field goal. While my right hand is up, making it a positive. Even means they're both going the same direction. Odd means they're going different directions, like this. But I need to make sure my right hand is up because it's positive. Negative, now my right hand is going to be down. Negative, my right hand should be down. My right hand should be down. Odd means I have one hand up, one hand down. Negative or even means they're both going the same direction. So here's a graph of an even function. Here's a graph of an odd function. Here's a graph of an even function, graph of an odd function. You can make another graph pretty easily. It can just be shifted down. Here's another, oh wait, I can do an even harder one. I can have a bunch of whoop-de-woos in here as long as my end behavior, what's really happening on the far left and far right, as long as I have some sort of field goal happening, I'm good. Another example of a negative, as long as I don't care what's happening in between, I could go up and down crazily, but as long as I'm going down like this, like an upside down field goal, that's still okay. I'm only caring about the end behavior. What's happening at the far right, what's happening at the far left with my hands. What happens in between, I don't really care about. We have other math that we just did yesterday for that. Again, same thing with the odd function. With an odd function, as long as I'm coming from the bottom left and doing some whoop-de-woos, it doesn't matter. As long as I'm having my right hand up, my left hand down. And then negative odd, same thing. As long as I'm coming down from the top left, I can have some whoop-de-woos as long as I'm going to the bottom right on my graph. All right. Are you guys ready for the dance? Make sure that you have all of this copied down. All of this needs to be copied down. All right, so we also need to have how to interpret some of these things. So they have some interesting notation. On your homework, you're going to be having questions that say, as x approaches negative, or as x approaches infinity. So the formal way that you don't need to write down right now unless you want to, this is saying, as x approaches infinity. Infinity. I'm missing some I's in there. There it is. This is what you do need to write down. What this is saying is what is happening on the right. As you go right.
As x approaching.
So what you need to write down now, oh, weird. As you go right. That's the translation. Or even better is right hand. What is your right hand doing? Quiet raised hand. As x goes to negative infinity, someone translate that. Instead of as x goes to positive infinity, how do you translate as x goes to negative infinity? Ellery. As you go left. Again, so you should be thinking your left hand. What is your left hand doing? What dance are you in? We're going to be doing this dance again on Monday for the warm-up. So as h of x approaches infinity, this is actually asking, is it hand up or hand down? We're going to be translating these again on the back. So make sure you have these memorized. So this is asking, what is your right hand doing? What is your left hand doing? Is your hand up or is your hand down? That's all it's asking. All right, here we go. Example number 1. We have this crazy polynomial, but we only care about the leading coefficient, which means, I love when you get to do this, cross off all of the math except for the leading coefficient. We only care about 4x to the power of 7. So you guys know this. With a quiet raised hand, is this a positive even, positive odd, negative even, or negative odd? It's one of those 4 choices. I need to see at least like 10 hands here, guys. Come on.
How do I decide?
I have 4 hands. So is this leading coefficient positive or negative?
Positive.
And is this even or odd? How many people know this? Oh, I got like 8 hands. I need 2 more. 2 more.
Odd.
Come on. More hands. More hands.
Odd.
2 more hands. 1 hand. I need 1 more hand. Come on. Chewy. Someone. I need 1 more hand.
Rosemary's hand.
Oh, you got it? Okay. Oscar. It is indeed a positive odd. Everyone. Positive odd. Where's positive odd? You should be doing positive, right hand up. Odd means they're going different directions. Positive odd. Thank you. All right, so now we need to translate this. So first of all, write positive odd. Or you can just write even this. Positive odd. So we know we're positive odd, and you can go ahead and draw your hands also. My left hand was down, my right hand was up. So it should look like something like this. Okay, as x approaches infinity, what is that saying? Someone translate that. As x goes to infinity. What is it asking for? Is it asking for something, India? What is your right hand doing?
My right hand is up.
And this is translated what, Jaden? My right hand is...
Infinity.
What does infinity mean? Is that up or down?
Up.
So that's saying right hand up. Someone translate this whole sentence right now in terms of your hands. Say it louder, Leo. Left hand down. Almost. Left hand up. Perfect. Left hand up. Well, was our right hand up and our left hand up? No, it's not A. Which one of these is it? All of these are always going to go right hand. It always, on Khan Academy also, it always starts right hand. Right hand, right hand. I'm just going to copy and paste this over and over. Right hand, right hand, right hand. On Khan Academy, it is always going to ask you for your left hand second. It's always going to go left hand, left hand, left hand. The only difference is your left hand up, down, and that's it. So this one is down, this one is down, this one is up, this one is up, this is down, and this is down. So, everyone, number of fingers. Is it A, B, C, or D? 1, 2, 3, or 4?
5, 6, 7.
Chewy Hood? Which one is it? I know you're copying down lots and lots of stuff right now because I was able to copy and paste. It should be option 4. Again, my right hand is up. My right hand is up. My left hand is down. My left hand is down. Correct answer is D. When you guys are working on the test or the homework, I want to be envisioning you guys doing the dance while you're doing the homework because that is how you solve these problems. You guys on your own right now, you are going to do example number 2. Work with each other, do your dance. Good luck.